Cancer, one of the most feared words in the English language.
Cancer rates are going to rise significantly over the next 20 to 30 years. But the driver of those rates are because there are 10,000 people a day turning 65.
According to the World Health Organization, cancer is the second leading cause of death globally, just behind heart disease.
There are 600,000 deaths per year in the United States from cancer. I think cancer is an inevitable part of biology, that cells will always accumulate mutations. Over time, some of those mutations will lead to cancer.
Over the past 30 years, cancer deaths decreased by 34% in the U.S., but diagnoses have gone up, especially among young adults.
What we are seeing is a troubling trend is younger people are getting more cancers. That's real. We have no idea why.
That rate of people under 50 getting cancer is growing by 1 to 2%.
Thanks to cutting-edge technology, today, doctors can detect and treat cancers earlier than ever before.
AI is really transforming so much of what we do. In clinical medicine,
cancer isn't just a disease, it's a multi-billion-dollar industry whose challenge is to balance the cost of innovation with the goal of patient care.
We have made tremendous progress. The problem we have is that we haven't communicated to Americans how complex cancer is. The drug companies do raise the prices in the United States because they can.
I'm David Rubenstein. For nearly a decade, I've interviewed some of the most interesting and powerful people in the world. Presidents, athletes, CEOs, entrepreneurs. I talk to them about their careers and their lives. Inevitably, we almost always end up talking about how they're living and how much they think about trying to live better. We're all trying to make sense of the mountain of new information available and the ambitious efforts underway to tackle the biggest health obstacles. On longevity, come with me as I talk with the leading experts in science and medicine and ask them the questions we all have: how to be healthier and ultimately how to live longer. What actually is cancer?
It's really a broad number of diseases, but it begins at the level of when a cell ends up with a genetic mutation that allows it in an uncontrolled way to divide. When we get to be adults, most of our cells don't divide. They stop dividing simply by contacting another cell. When they run into another cell, they stop and they've reached their process of division and now just do their function. Cancer is when a cell in that process of dividing at any level, actually driven by inflammation or other factors, when there is a genetic mutation in that cell, now that promotes uncontrolled division. And it really doesn't care about boundaries.
Well, historically, it was thought, I believe, that the older you were, the more likely you were to get cancer. Is still aging the principal thing that we see associated with cancer?
Cancer rates are going to rise significantly over the next 20 to 30 years. We know that we're improving outcomes alongside of that, but the driver of those rates are because there are 10,000 people a day turning 65. The highest incidence of cancer is that post-65 group. As you get older, you have greater risk of what we call somatic mutation. Those are mutations that develop over time. They're not that they're inherited at all, but they do drive cancer when they actually occur as people get older and live longer.
600,000 people die a year from cancer in the United States?
yes.
Is that a higher number than 10 years ago or 20 years ago?
It is a lower number. It has been decreasing by about 1.7% per year. And so we have many people alive now who wouldn't have been alive if they had been diagnosed.
When someone is diagnosed with cancer, doctors determine what stage it's in. This helps them understand how far the cancer has spread and how best to treat it. So what are the stages of cancer? Stage 1 is the earliest stage. Think of it as a small tumor that's still in one spot. It hasn't gone anywhere. It's usually less than 2 centimeters. Doctors call this localized. Stage 2 means the tumor is getting bigger and may have started moving into nearby lymph nodes, which are part of the body's immune system. At stage 3, the cancer is not only larger, but it's spread into surrounding tissues and more lymph nodes. It's more serious, but still may be treatable. Stage 4, the most advanced stage, means the cancer has traveled to other parts of the body. This is called metastatic cancer. When survival is talked about, it's measured as 5 years. In other words, how many people are still alive after 5 years. So if you have stage 1 breast cancer, it's detected, and you have treatment, you have a 98% chance.
That's right.
But there are some cancers where it's the opposite, where even if you detect it in stage 1, you had a really tough chance. And I thought they were glioblastomas, pancreatic cancer, liver cancer, esophageal cancer. Are those some of the most deadly ones?
I would say at the top of that list, on a scale of 1 to 10, and it's 12, is glioblastomas, right? There is a difficulty, but better chance if it's detected early that you can resect it, but still very difficult to cure because of its aggressive nature within the normal brain cells and the inability to resect enough brain tissue to make sure you got it all. Because brain tissue is valuable. You don't reproduce it. And what's the survival rate for pancreatic cancer if the tumor was less than 1 centimeter? It approaches 90% if you can get it that small.
But how does anybody know they have it in stage 1 because there's no signs?
It's accidental. It's incidental finding. And that's all of those cases where nobody was looking. Somebody got a CAT scan because they were in a bad car accident, and the radiologist saw this tiny nodule in the pancreas and said, we better have that looked at with a more descriptive test or a more discrete test, and then they see it, go see the surgeon. And that's the only way we've gotten that benefit.
While cancer risk is typically higher in older adults, new research shows a concerning trend. More young people are getting diagnosed with certain types of cancer.
There is a rise in young people, particularly with colon cancer, but a few other cancers, breast cancer, renal cell carcinoma, and others. And even though we are decreasing the mortality from colon cancer in people over the age of 50, mortality is going up from colon cancer in people under age 50. And the reason for that is not entirely clear.
Colon cancer screenings are now more common among younger adults. A recent report from the American Cancer Society finds screenings for those aged 45 to 49 jumps from 2019 to 2023. And with that surge, more cases are being caught early.
All of the regimens we have, surgery, chemotherapy, were designed around people who are older with cancer. I do think the biology of younger cancer is very different. So first of all, we need to develop regimens meant for younger people. That being said, we also have to start screening younger people for cancer. The age of colon cancer screening dropped from 50 to 45 recently, and it probably should drop even further.
Doctors agree, early detection saves lives. Colon cancer, when caught early, has a cure rate above 90%.
Colonoscopy is the gold standard. You're actually putting a scope into the colon and you can actually see the cancers, right, or the precancers. There are other ways to do it too initially, like Cologuard is approved. It looks for genetic changes that come off of the colon lesion and get into the stool.
So what's driving the surge in younger patients?
It's an area of very active research, but the thought is that diet and lifestyle changes, likely from early childhood, are a major part of that risk. And another part of it is the microbiome, which again is related to diet. Some bacteria in our gastrointestinal tract can promote the development of cancers, and that is modulated by our diet.
Doctors and researchers still don't know what exactly about a patient's diet is the culprit, but they're working hard to figure out what's driving this trend.
These drugs just prevent the stop signal so that these immune cells, which naturally can recognize something that's different in the body, and they allow those cells to fight and kill the cancer.
While not all cancers are preventable, experts say there are ways to reduce cancer risk. The consensus is that changes in behavior and lifestyle can make a significant difference in the long run.
I think the practical things, David, that most people do now is avoid smoking or around areas where people are smoking. Secondly, take advantage, if you would, of the screening tools that we know work: colonoscopy, mammography, skin exams. Stay out of the sun. Limit the alcohol that you take. Get the appropriate vaccines, like for hepatitis B and HPV, that can allow that to be a prevention for doing it. and exercise and maintain a good weight level. The final piece I would say, limit your red meat intake. Have a balanced diet, but don't ply it with a ton of red meat.
There are many other types of early detection that are under investigation. One of the ones that's really active right now is a blood test that can detect little snippets of DNA from a cancer. And it's a very alluring idea that you could just get an annual blood test and detect any kind of cancer. That hasn't been proven yet. They're commercially available, they're under clinical trials, but they're not proven yet to decrease mortality from cancer.
And it's know your family history. Figure out what Aunt Marge died from and really understand, because many of those family histories carry down from person to person.
Now, on prevention, sometimes if you have a genetic predisposition to a certain type of cancer, some people have treatment. For example, women have had mastectomies.
That's right.
Because they have the so-called BRCA gene.
That's right.
Is that generally more on the rise, that people do a relatively small subset of the population?
It's actually a much larger subset of the population than we understood not that long ago. Maybe 10% of all of our cancer patients have some major inherited predisposition to cancer. And just as you said, if we know about that specific inherited mutation, we are able to tailor our cancer prevention early detection strategies towards that mutation.
Okay, so if you have your genome completely tested,
yes,
you will presumably know whether you have a genetic predisposition. Do you recommend that people get their genome tested?
So it's not currently recommended that everybody does, and it's really a personal decision. Do you want to know all of the risks that you genetically inherit or not? However, if somebody has a strong family history of cancer, multiple members of the family had cancer, maybe they had cancer at a young age, those individuals are at higher risk, and those are the ones who more often get tested. And you don't need to test the entire genome. You can just test the particular genes that lead to cancer predisposition.
For a long time, cancer treatment mostly meant surgery, chemotherapy, or radiation. But in the past decade, we've seen some big breakthroughs. Immunotherapy started making headlines in the early 2010 period, with drugs like Keytruda and Opdivo.
These drugs actually are inhibiting stop signals on specific immune cells called T cells that have the ability to see cancer as being different from the normal cells they derive from. These drugs just prevent the stop signal so that these immune cells, which naturally can recognize something that's different in the body, and they allow those cells to fight and kill the cancer.
Unlike chemo, which attacks cancer cells directly, immunotherapy works by training a patient's immune system to recognize and fight cancer cells, just like it would a virus or bacteria. Now, my former boss, Jimmy Carter, who passed away less than a year ago, he had melanoma that went to his brain, and I thought it was with immunotherapy that it disappeared.
He did.
How did that happen? I mean, how does it disappear so quickly?
Well, so one, the melanoma he had a significant amount of targets that the immune system could recognize. And the drugs that he received unblocked the immune system's view of his tumors. And because the immune cells go everywhere in your body, even the brain, they can wipe it out in a very intelligent way. That is, they spare the normal tissue around it, but really take out the specific cancers because of their targets that are often in the cell and on the surface of the cell.
Though immunotherapy isn't prescribed in all cases, as it depends on the type of cancer and how the body responds, it's one of the most exciting advances in cancer care, offering hope to patients who once had few options.
Since 2011, we've probably had more than 50 approvals of several of these drugs for different cancer indications. And if you take a look at the survival rates of some of these cancers, like lung cancer, malignant melanoma, some colon cancers, you'll see that the survival rates have almost doubled for advanced stages of these diseases. They've been very successful and have really changed how we treat patients with these really bad cancers.
Another development in cancer treatment over the past 20 years targeted therapies. These are drugs designed to zero in on specific genetic mutations in cancer cells. Instead of a one-size-fits-all approach, they're more precise, blocking the signals that help cancer grow, spread, and survive. And as scientists learn more about the biology behind different cancers, they're uncovering even more ways to target and to attack it.
We have had many new drugs in cancer over the years. In the last 30 years, about 300 drugs have been approved by the FDA, about a third of them for cancer. So really a huge number of new drugs for cancer.
Now, researchers are looking beyond the lab for breakthroughs. Doctors say artificial intelligence is revolutionizing cancer research, enhancing diagnostics, improving treatment strategies, and advancing drug discovery.
AI is really transforming so much of what we do. In clinical medicine, AI has the ability to do image analysis extremely well. So cancer pathology, looking at the slides and making diagnosis, cancer radiology, looking at MRIs, CT scans, and finding evidence of cancer. Those are clearly fields that are being transformed. AI is helping our basic research. The structure of proteins can now be predicted with AI in a way that we couldn't possibly have imagined not that many years ago. That was rewarded with the Nobel Prize last year. And we use AI-generated structures of proteins for drug development on a daily basis now.
Among the criticisms of the American medical system is that we have very expensive drugs compared to other countries. And among the most expensive drugs that we have are cancer-related drugs. Why are cancer-related drugs so expensive in the United States?
Countries with national health care systems have negotiated with drug companies for lower costs. And drug companies actually like our system where they can charge more and get paid more. Now, it does cost a lot to get a drug approved, but I think that we could still reduce the cost of drugs and in the United States, and drug companies will still make money and be able to get the approvals. One of the concerns that many of my colleagues in drug companies raise is that it costs a lot to do the research and development. And they're worried that innovation will be reduced because of if we reduce the cost of drugs.
So what do you think the U.S. government can do better than it's doing now to help with cancer research, or you're reasonably happy with what the government's doing?
The recent decades of government funding to the National Cancer Institute have truly transformed the disease. Scores, more than 100 new drugs that are really completely transforming the disease. At this moment, government funding for the NIH is in turmoil. There's proposals to cut the NIH budget and the National Cancer Institute budget enormously, and that would have a catastrophic effect on the careers of many cancer researchers, on the progress against cancer and the development of new therapies.
Right now, the U.S. government is making it more difficult for vaccines to be funded and so forth. Is that going to affect cancer vaccines or not so much?
I hope it's not going to affect cancer vaccines, but mRNA vaccines are very important vaccines, not only to prevent infections, but also to prevent or treat cancer. And there's likely going to be an mRNA vaccine for melanoma, the first vaccine for treatment. The data looks really good in phase 2, so it's now being tested in phase 3. I really think we need to educate people that these mRNA vaccines are very safe. I'm very concerned by what's happened where our HHS has decided to reduce or even eradicate any funding for mRNA vaccines against infection, because we are at risk for future pandemics. It's going to happen.
Well, what always excites me most is what we can't imagine right now. Breakthroughs in cancer research and cancer treatment have come from left field that we didn't expect it at all, and was a huge breakthrough.
A nationwide study analyzed breast cancer screening data from 2018 to 2020 and found major disparities. Researchers say where you live, how far you are from a mammogram facility, and your education level all play a major role in whether you get screened. The findings highlight the urgent need for policies to improve access, especially in underserved communities.
One of the biggest disparities in outcomes in cancer in the United States is rural versus urban. In New York or in Boston, people can come to a cancer center with highly, highly specialized doctors who see only pancreatic cancer or only colon cancer, and they know every nuance of those diseases. In a rural area, that is not possible. You couldn't have subspecialists in all of those subtypes of cancer locally because it's too sparsely populated. The hope is to diagnose patients as efficiently as possible, to figure out which patients can get a standard therapy close to where they live, and which patients need very advanced therapies like a bone marrow transplant or cellular therapies that are really only delivered in tertiary care centers, and to get those patients to those hospitals.
We've purposely at Memorial worked hard with both underserved communities and immigrant communities to make sure they have an opportunity to have access to the best care possible. That often means partnering with organizations that both follow guidelines and rules about the status that people may have, but also follows and creates a safe environment for people who live in a place where they're used to their hospital, they trust the people there, but that a hospital doesn't have the cancer infrastructure.
What is going on in cancer research now that excites you the most about the possibility of reducing cancer or improving cancer detection and reducing the incidence of cancer?
Well, what always excites me most is what we can't imagine right now. Most of the really transformational breakthroughs in cancer research and cancer treatment have come from left field that we didn't expect it at all and was a huge breakthrough. Another area that I'm really excited about is new drugs target proteins in general. And most proteins were considered undruggable. We just didn't have the chemistry to make a small molecule, a drug, attack a particular protein. And we have new chemistry, new approaches now to make many of those so-called undruggable targets now druggable. And there is so much creativity going into that field right now that we are creating all kinds of drugs that we couldn't before.
Some people would say the most despised word in the English language is cancer.
Yeah.
When somebody says you have cancer, that's about the worst thing you can hear. How do you tell somebody that they have cancer?
What I would say is that when you have the opportunity to detect a cancer and you're now seeing a patient who's going to get treated, that conversation is a holistic one. It's not only the diagnosis, but it's also that we're here to walk this journey with you.
Now, more than 50 years ago, Richard Nixon declared war on cancer. Have we really made a lot of progress since that war was declared?
When Nixon declared the war on cancer, there was an enormous amount of cancer biology that we just did not understand at that time. And the huge triumph of the war on cancer has been our deep understanding of how cancer works, what causes cancer, and how to treat it. And I would say it has been a success in the sense that we have this tremendous number of new drugs that have been created because of that understanding that now transform the treatment of cancer.
I think we're in a golden age. I think we're going to have massive impact over the next 10 to 15 years. Whether we cure it all, I suspect that cancers are pretty smart. There'll be some that we'll still struggle with, but the difficult ones we will make an impact on.
I'm David Rubenstein. This is Bloomberg.